All right, next up we have Tamas Piros, and he is a Google developer expert, and he's also a developer evangelist, a seasoned developer evangelist, and he'll be talking about WebAssembly. So let's roll his opening. Hey, Tamas, welcome.
Hello.
It can't be a JavaScript conference without a WebAssembly talk, so I'm looking forward to this one to see the advances in WebAssembly, see what's going on there. I know it's made some progress. So tell us a little bit about yourself, Google Developer Expert. That's quite a title. I'd like to be some kind of expert.
No, it's a very good program actually. So if you work on any of Google's products and you worked and you have something to show for it, then you can apply for this program, and then you get some sneak peeks and product updates and some nice internal meetings with Google folks. So it's useful. I like it.
Awesome. So I myself am looking forward to hearing what you got to say about WebAssembly and JavaScript, and we'll let you take it away and stick around because we will ask you questions afterwards. So make sure to be here.
All right. I'm going to start by sharing my screen, and thank you for the opportunity to present at this conference. And also I want to say hello and welcome to all the attendees as well. And as the title says, we're going to talk about how you can supercharge your JavaScript with WebAssembly. So I'm not going to do the introduction because that was a very quick one that I had. So I'm just going to skip this. And I'm going to jump straight into the talk. And I'm going to roll back the wheel of time to 2018, where this is how, in a very simplified way, how the web platform used to look like. So inside your browser, you have access to various APIs and various bits and pieces. But the two key things that I want to point out to you is that you had the web APIs, and these are the fetch API, the Bluetooth API, the notification API, and all sorts of other APIs. And you also have this sort of virtual machine that allowed you to essentially interpret, compile, and execute your JavaScript code. So this is a very simplistic view of what happened on the web inside your browser, essentially. So just remember this, because we're going to come back to this picture, and we're going to update it with how the web platform looks like today. Now, of course, if we compare 2018 to today, and if you take a look at the past 5 to 10 years on the web, there's no denying the fact that the web has progressed at an incredible pace, right? More websites, more content, more frameworks, more tools that we have at our disposal as developers. And JavaScript pretty much dominates the web scene, right? It's not only vanilla JavaScript, but all these frameworks and libraries that are out there, all the tooling, and of course Node.js. So JavaScript is everywhere. But because of reasons and because of the history of JavaScript, it has certain limits, it has certain limitations, and there are some use cases and there are some scenarios where JavaScript can work, but it may not be the best tool for you to use, right? There are some situations where JavaScript may not perform well, or may have some short sides or shortcomings even. And you want to make sure that, in today's fast-paced web, where consumers are really just, want to press a button and they want to see some action, you're not hogging their system with some potentially slow JavaScript. So also, if you have, some use cases in your application where you want to achieve low-level tasks, sometimes you can do these tasks using JavaScript, but there are some scenarios where these low-level tasks are also just impossible to do because, maybe there's no functionality available for you in JavaScript, there's no library for it, or it's just, JavaScript just physically can't do what you are attempting to do on the web today. And this is when we need to talk about this thing called WebAssembly. So WebAssembly was created in 2015, so about 5 or 6 years ago. And also before that, so in 2013, there was this a library called Asm.js, which, if I remember correctly, it was developed by Mozilla or the Mozilla Labs. And with Asm Js, what you could do, you could essentially take applications that were written using the C programming language and run those on the web, right, inside your browser. And that's really it's really predating WebAssembly, but effectively WebAssembly does the same today. And the great news about WebAssembly, and especially for all the people out there who love standards and love specs, as of December 2019, WebAssembly is an official W3C recommendation. So that means that how HTML and how CSS is part of the W3C recommendations, WebAssembly also has its standards. So it's being looked after, it's being developed, and it's an active part of the web ecosystem. But what is really WebAssembly? What is the official description? And I kind of copy-pasted this from Mozilla. And they said that WebAssembly is a low-level assembly-like language with a compact binary format that runs with near-native performance and provides languages such as C, C++, and Rust with a compilation target so that they can run on the web. So that's a mouthful. That's a very good description. But, you have to read it once or twice to kind of fully comprehend what WebAssembly is. So I came up with a much simpler explanation, which is run native apps on the web. And by native apps, I mean applications that were written in another language that would be considered to be outside the traditional web languages, so like C++, C, or Rust, so on and so forth. So what WebAssembly allows you to do is to take those applications and run them on the web. Now, that sounds great, but how would you do that? What are what do you need to do to achieve this, essentially? Now, before we get to that, we also need to talk about this connection between WebAssembly and JavaScript. So you're going to see a couple of examples that I'm going to show you, but essentially what you can do is expose functions that you have in WebAssembly, which ultimately are functions that you have in C and C++ and other low-level languages, and you can expose them to JavaScript. You can make those functions available to JavaScript so that you can invoke those from your standard normal web application. You can pass in arguments, and WebAssembly can parse those arguments, do calculations, and then send you back a response. But we're going to talk about this a little bit more in detail. Now, one thing that I would like to clarify as well is a lot of times I've heard people saying, this was true maybe 3 and 4 years ago, that WebAssembly is coming and that's the next big thing, and it's going to be really, really important, and it's going to take over JavaScript, and it's going to be the dominant sort of language or technology on the web. And I have to fundamentally disagree with that, because WebAssembly is not something that was created to replace JavaScript, but rather it's here to enhance or to augment the JavaScript. It's essentially here to make JavaScript even better, to allow JavaScript to achieve the things that it can't do because of historic reasons, or because of performance reasons, or because it just physically can't access the stuff that it needs. So it's very important to remember this, that WebAssembly is not here to replace JavaScript, but instead it's going to make JavaScript even better. So if we go back to that sort of drawing, or to this figure that I showed you on the first slide, how the web platform looks today, and again, remember, this is just an overly simplistic view. You still have the web APIs, right? The web APIs keep on being extended, and in fact, one of the latest extensions to the web API is called the Webassembly Javascript Api. But if you look at the other part of this picture, the virtual machine, so now in most modern web browsers, you're not only able to compile and interpret and execute JavaScript code, but you can do the same for WebAssembly. Okay, so you can now officially compile and execute WebAssembly code in modern browsers. And because, it's kind of the same engine, right? So in the case of Chrome, it's the V8 engine that takes care of both of these things. There are some added benefits to this, things like, shared memory or shared virtual file systems and other things that you can leverage both from your JavaScript code and from WebAssembly as well. So, I said, a new API. So there's this thing called the WebAssembly JavaScript API. It has sort of two ways for you to take a WebAssembly module and then import that into or add that to your web application. And there are, a bunch of methods in this WebAssembly JavaScript API that allow you to do that. But effectively, you can, and that's the most popular way of doing that I've seen so far is, you would load a WebAssembly module by way of streaming. And you would use this streaming because this streaming method would take that WebAssembly module and effectively take that WebAssembly module's bytecode and turn it into a module or turn it into an instance. And because it is now a module inside your browser, inside your JavaScript code, it pretty much behaves just like how any other JavaScript module would behave, right? So you can import it and you can access the functions from that object. Now, if you don't want to use streaming, you can also load WebAssembly modules without streaming. And when I say streaming, it's the method is actually called initiate streaming. So that's why I keep on saying streaming here. If you want to load a WebAssembly module without streaming, you can still do that, but you need to do some additional operations to, as I said, take that bytecode and turn it into a module. So that's why most people would prefer loading modules via the streaming method. So how do you create a WebAssembly module? So there are two ways that I'm going to share with you today. One is, you have some code or you write some code in C or C++ or any other what is called LLVM supported language. So LLVM is a compiler architecture. So C, C++, and some other languages utilize that. So you create that code and then you use a tool called mscripten, which has a command line interface that has an emcc command, which is the mscripten compiler, and you tell it to use the C file and then generate a WebAssembly module. So you specify WebAssembly as your compilation target, and then that is the WebAssembly module that you're going to load and consume using the aforementioned WebAssembly JavaScript API. Now, the one thing that I kind of, it's my bad, I forgot to add here is that mscripten also produces a JavaScript file which acts as what they commonly refer to as glue code, which is a glue code between the WebAssembly module and JavaScript functionality that may not exist in the browser. So that's, all of that is done for you automatically. So that's one way of creating WebAssembly modules, while another way would be to use a non-LLVM language, for example, a .NET language, a Ruby, or even Go, because these languages also allow you to compile your code to WebAssembly. So you write your Go application, you compile down that to a WebAssembly module, and the rest of the process is going to be the same. You load and consume that WebAssembly module inside your web application. So that being said, you now see that, if you are familiar with another programming language, so one of the .NET languages, a C, a C++, C#, D, F#, Go, Java, PHP, Python, etc., it's going to be very easy for you to create a WebAssembly module. And in fact, this person on GitHub actually collected all the programming languages that have WebAssembly as a compilation target. So it's a very, very useful list. And I also want to add that if you are a TypeScript developer, you may not be aware of this thing called the assembly script, which kind of advocates itself as a TypeScript to WebAssembly compiler. It is true, but it's not that you take your TypeScript code and then you compile it down to assembly script, and then you use assembly script to then compile to a WebAssembly module. But assembly script feels and looks a lot like TypeScript. So that's why I'm saying that if you're familiar with TypeScript, it may be easier for you to create a WebAssembly module than you think. And last but not least, before we get to the demos, I wanted to share a couple of use cases with you, at least at a very high level. You know, when would you, or what are the scenarios when it makes sense to use WebAssembly in your web application? And of course, the first point is, making use of existing code. So you may have some C or C++ code already written that does something. One particular example would be, I'm going to have a demo of that that I created. Other examples could be maybe you want to convert images to AVIF and you want to do that in a very performant way. Now, JavaScript has some image manipulation libraries that support, WebP and JPEG, but maybe not AVIF. So you need to tap into some code that you may have written using another language and then port that to the web. Performance is another thing. And I'm going to actually clarify that. I'm going to say reliable performance with WebAssembly. So there are some differences between how JavaScript and WebAssembly performs on the web. Generally speaking, they could perform very, very similarly. However, there are some scenarios where WebAssembly outperforms JavaScript, but also in terms of the entire compilation interpretation of your code, the performance of WebAssembly is more reliable, it's more predictable by the V8 engine, and therefore its performance may be better. And also, because WebAssembly is something that is being actively developed, there are features like threads, shared memory, SIMD that you have access to that otherwise would be inaccessible from JavaScript code. And last but not least, binary size. So sometimes creating something in JavaScript and creating the same thing in WebAssembly would mean that your WebAssembly code is going to be much smaller. And also, WebAssembly files compress really, really well using gzip or Brotli compression. Okay, so these are some of the use cases that I wanted to mention. So time for a demo. So what I'm going to do is open my editor, and hopefully the font size is large enough so that you can see what I'm going to share. And I'm going to start with a C example. So I created this file called square.c. It has a method, accepts a parameter, and it returns that particular number squared. Okay, and then I executed this emcc command. So that's the mscript and compiler. So I took square.c and I created a WebAssembly file, and there's also a square.js file, which is the glue between the WebAssembly and the JavaScript runtimes. And then what I've done, I created this index.html where I edit the square.js file, and then I essentially load the WebAssembly module into my application, and I can directly access the inSquare method from my C application. And here, and I expose that as a JavaScript object with an API by the name of API that has a method called calculateSquare. And then I will also show you the front end. I have an input box, and I have a button, and I have an event listener for that button. So if someone presses that button, I just call the calculateSquare method, which is going to invoke the inSquare method, which is now in WebAssembly. So effectively, I ported this very, very simple C application to the web. So I'm going to open up this server, and I'm going to go to my browser. And let's see here. Go to localhost 8999. To zoom in a little bit. So here's an input box. I press calculate, and then I get a number. So this number does effectively come from WebAssembly. Now, I know what you're thinking. This is not the best sort of use case because this is just a very simple calculation. And of course, you can do such calculations in JavaScript, but that's not the point. The point is to show you just how easy it is to take something in C and import it to the web. So this is an LLVM language, but I created another example, which is right here called cube.go. And you can probably figure out what this function is doing. It takes a number and then it basically multiplies the number 3 times. So it's returning the cube of that number. Now you will see that things are a little bit different here, because inside my Go file, you see something like document, get element by ID, result, inner HTML. That looks awful familiar, right? Now the difference between a C and a C++ and a Go is that I can access my document object model directly from this Go file. So when I compile this particular file down to WebAssembly, it will be able to manipulate the DOM because of how I have access to this JS global inside my inside the context of my Go file. Now, if I open index.go, you will see that I use this instantiate streaming. So I effectively will stream that particular WebAssembly module. I use the fetch API to fetch the WebAssembly module. And what I forgot to tell you was that I executed this command from Go to compile to a WebAssembly module. And notice here that I have the same example. So when I click the button, I'm going to call the cube function, and I don't need to do anything special because the function name here is the same name that I have specified inside my Go file. So there's a direct link between Go, JavaScript, and this WebAssembly module. So think of it as the WebAssembly module being the bridge between the two things. So what I'm going to do here now is go to index.go.html, and then I'm going to add the number. Now I get that number cubed. Again, the calculation happens using WebAssembly. But these are just very, very basic examples. Let's take a look at some more advanced examples. And I have one here, and I have a prelude to this. Let me show you why I'm going to show this example to you. So consider we have this image uploaded to a service called Cloudinary. And if I just refresh here, we will see that this image is 583 kilobytes in size, and it is a JPEG image. So what Cloudinary does, it allows you to store, optimize, transform, and deliver your image assets. Now, we do a lot of optimization of these images. So I am going to type, and probably you can't see this, but I'm going to explain and show this to you in just a moment. So I typed in two things to the URL, which are photo and qauto. So this is going to generate the appropriate image format for the browser that I use, as well as reduce the quality of the image in a way that is not affecting the human eye. So it's going to do a lot of work behind the scenes. And in fact, if we take a look now, the same image is just 32 kilobytes. And because I'm using Chrome, it comes back as a WebP image. So this is great, but what I wanted to do, I wanted to go many, many levels deeper. I wanted to know, what kind of WebP is this? Is this a WebP with an alpha channel? What kind of WebP container am I using? Is it a VP8 container? Is it a VP8L container? So on and so forth. And of course, this is something that I can't do using JavaScript today, but I can do that using Go because it has, a WebP library that I can use. So I'm not going to go through all of the code here, but effectively, I basically take a look at the bytes and I do some, parsing of that data. And then based on that, I get a lot of additional information about the image itself. And I do the same for PNGs, and I do the same for JPEGs. And this particular tool, oops, I'm using this address already, so let's stop that there and let's come back here. So this particular tool that I created, which is right here now, oops, we don't need that. There we go. Allows you to effectively take a look at an image. Let's use the same image. And with the photo tag, let's do a check. I am now seeing a WebP, which is true, but I can say that this is a lossy WebP. It doesn't have an alpha channel. And in fact, the container for the WebP is a VP8. I could change this to say, let's do a PNG image as well. So it basically allows me to analyze the image a lot more in depth because I'm using WebAssembly. So this is stuff that I couldn't have done using just JavaScript. Maybe I could have done it. Let me actually rephrase that. But it could have been a lot heavier, and I would have needed a lot of additional code. And then the last example, really quickly here, is this C++ application was written by one of my colleagues a couple of years ago. And it basically allows you to compare two images, and it's going to tell you if the images are the same or different in terms of quality. And I thought that this is a great tool, but it was only accessible via the CLI. So what I've done, I ported this to the web using WebAssembly. So I'm going to start this up, and we're going to take a look at that as well, just real quick. And that's going to be the last thing that I want to show you. So that's the same port. So let's come here. And here we have two images, right? So this is the first image. So I'm just going to open this. This is going to be a black car. Perfect. And then I have this Q1, this quality 1 image, which I'm not sure how much is going to come through the stream, but hopefully you see that this isn't a really ugly image now. So clearly these two images are the same, but because of these visual defects, they shouldn't be considered the same. So when I click this button, this is actually going to invoke that C++ code, and it's going to tell us, well, 0.4, these images are not the same. But if I put QAuto, Cloud Engine will automatically reduce the quality in a way that, as I said, is not affecting the human eye. Is it true? And as you can see, that C++ library is in fact telling us that it is true, because the closer this value is to 0.
All right, sorry about that. We had a small technical difficulty at the tail end of Thomas's really great talk when he was comparing the two images. So if you want to just wrap it up, Thomas, you're still here and it's still in your slot. I'd love to hear what you would want to say.
Yeah, what I wanted to add, or what I was actually saying, but I didn't notice that I wasn't in the stream anymore, was that I'm going to leave you with these resources. So, links to the repositories of my code and some, various resources that you can take a look at about WebAssembly. Squoosh.app is another great app that uses WebAssembly. That's a tool by Google. There are also games available today on the web because people ported those to the web using WebAssembly. So, have a look at these. And that was really my last slide. And with that, I just wanted to thank you again for the opportunity and for the attendees to listening to my talk.
Awesome. So great talk. WebAssembly.
Thank you.
When will it become much more popular, I guess, mainstream? I feel like now it's getting there, but it's not quite yet. How are you feeling about its potential?
I think it's so for use cases where where there's lots of image processing, there's lots of processing. People are already using WebAssembly. So Squoosh.app is using various image compressions and image optimizations inside your browser. They are using it today, and they've been using it for quite a while. I've seen a particular museum, I think in the Netherlands, who actually had virtual walking tours of the various parts of the museums available on the web in your browser. They also use WebAssembly because they realize the performance potential and just how smoother that experience is. That being said, the developer tooling is also getting better. So I think Google a couple of months ago just announced that you can now directly debug the source of your WebAssembly file, so that you can debug your C or C++ code directly in your browser using DevTools. So when you combine these things, and when it's going to be sort of more convenient and easier for developers to debug and to work with WebAssembly, I think more and more people will start to use it.
Awesome. And how do you see the kind of the WebAssembly JavaScript integration? Is it becoming more native? Are they working better together? Do you think they influence each other in terms of performance, and what kind of a little bit on that?
So because they run on the same engine, I think it's very easy and convenient for the developers behind V8 as well to provide with all these integrations. So just recently I learned about this shared array buffer thing, which was a new thing added to JavaScript just so that WebAssembly can also share memory with JavaScript. And then they have all these very interesting tight integrations. And I just learned about the Atomics API in JavaScript, which even if you ask me to explain what it is, I still can't. But it has to do with shared array memory and buffers and WebAssembly. So it's getting there, and also because both are, standards, it's just a good mix, I suppose.
Awesome. And just a little bit about implementation. So can I use WebAssembly in my PWA? Is that something that's being done?
Yes. So if you think about progressive web apps, you can cache and make all your sort of assets offline, available offline. So all your HTML, your CSS, and JavaScript. And because you have a WebAssembly module that is just a file, you can also cache that. It is going to be available offline. Furthermore, it can tap into sort of the lower level details of your mobile device, for example. And in fact, if you take a look at scrooge.app, I think that's a progressive web app as well. And when you sort of install it, it's going to also install the WebAssembly module and all the other assets that you need. So it's, again, a very good combination that you can use in the web and with, of course, progressive web apps.
Awesome. What a great talk. Thank you so much for being with us and joining us at JSday. We hope to see you.
Thank you for having me.
Have a great day and join us for the next one.
You too.
Thank you.